Hello, everyone. Welcome joining the webinar exploring the next frontier of systems engineering SysMLv2 organized by Dassault Systems and OMG. Many thanks for this organization, especially for OMG, to having everyone here. This exclusive technical session will showcase the cutting-edge integration of SysMLv2 into the Cameo Magic portfolio. The webinar speakers are the real experts in the field: Andrius Armonas, Nerijus Jankevičius, and Tomas Vileniškis. I'm putting them on the stage. So before starting session, again, thanks for OMG. During and after the presentation, everyone will be able to ask questions in the Q&A section, and speakers will take some time to answer them at the end of the webinar. So we have a good session, and Andrius, the stage is yours.
Thanks, Gitana. Hello, everyone, and welcome to the webinar, where we will be touching a lot of aspects around SysMLv2 as a language, and also we will be disclosing a lot of new things that we actually implemented in our product portfolio to support SysMLv2. So in this slide, just some information about myself. So I'm the SysMLv2 implementation lead at Dassault Systems. And I'm a long-time employee at Dassault Systems, ex-Nomagic employee since 2007. I'm also a representative, Dassault representative at the OMG SysMLv2 and kernel finalization task force, as well I'm co-leading the OMG RAML revision task force. So RAML is a standard for integrating safety, reliability, and cybersecurity aspects into MBSE. So most of the things I do is actually around SysMLv2 implementation vision, and also the roadmap, understanding the market, and things like that. You can see the link to connect with me on LinkedIn. Also, you can scan the QR code. So let's be connected. And I am posting time to time very interesting news on what we do in terms of SysMLv2 and not only. So this is our agenda for today. We'll start with the status of SysMLv2 standardization, about the values of SysMLv2 as a language, and then I will actually show the implementation details of what we have and what's coming around the corner. Actually, we are releasing the public version of SysMLv2 implementation right before Christmas. And yeah, so I'll show a lot of modeling stuff in there. Nerijus, my colleague, he will be focusing on simulation, execution, evaluation topics. And Thomas will be presenting how we support SysMLv2 RESTful APIs, as well as collaboration aspects. So let's get started. So if we think about where we are today in terms of MBS adoption and tool adoption, so yeah, SysMLv1 implementation that we have, everyone knows it. It's called Cameo, Katia Nomagic. It basically goes under different names. So honestly, it's the de facto standard for doing MBSE, and that's the most popular solution. So if somebody is thinking about adopting MBSE, they choose Cameo, usually. In the meantime, we are working on the SysMLv2 implementation. And to date, I would say we definitely have the most powerful solution there in terms of features. It's definitely very much integrated, right? You don't need 5 tools to do MBSE with SysMLv2. You just use Cameo for this. It's very well integrated, and it's definitely 100% standard compliant, just like our SysMLv1 solution. That's a core value we have, and we have 2 programs for early access running. One is called Early Access Program. If you want to co-develop with us, the SysMLv2 solution. And also we have another program called Early Experience Program, EEP, if you just want to learn and understand where we are going, or maybe if you just want to learn the language. Okay. Just like I mentioned, we are releasing the public version of our product in 2026X release, which is again at the end of November or likely at the beginning of December. So if we look at who is using our products, of course, our customers, but also we are very proud that thought leaders are using it and are choosing our implementation. like Sandy Friedenthal and Tim Wilkins. Sandy Friedenthal is the father of SysML v1 and v2, and he is using our products on a daily basis, like many experts out there. And the reason is because it's very user-friendly and standard compliant. And actually, they are writing books. All future books, from what I know, on SysMLv2, our tool is used to produce diagrams in there. So which is really nice. Now, if we look at where we are in terms of standardization, so I put this slide. At the top of the slide, you can see that OMG started the process in 2017 with the RFP for SysMLv2, and now it's 2025 that we have the final steps in the specification adoption. So we need to be very clear. The spec is not yet approved. I mean, it's approved by the architecture board at the OMG, but it's not released publicly. So there are final stages, but it's not publicly released just yet. In the meantime, just like I mentioned, we are providing early access to our products, and it's already a huge success, but I get many questions in the public release, in which products it's gonna be implemented. So the short answer, it will be available in Cameo, in CATIA Magic, in Teamwork Cloud, and in 3D Experience Platform. So pretty much everywhere you would expect it to be available. Now let's look at the objectives of SysMLv2 language. And this slide is coming from the OMG. And the first is thing that it's more precise and expressive language, meaning it's more powerful than V1. But at the same time, it means you will need to learn a little more as an expert. Then consistency and integration among language concepts is definitely increased because, well, you can immediately notice that if you learn one part of the language, for example, structures, it's relatively easy to learn how to model activities or states because patterns are used across the language. Interoperability with other engineering models and tools, definitely it increased because now we have a standardized V2 API, which we support, by the way, in 26x. Usability, my model developers and consumers, yes, I do agree, especially for basic modeling usage scenarios. So basic models, it's easier to create using this language. Extensibility is very well supported. We have metadata, we have libraries, so two mechanisms to extend the language. And we definitely support it as part of our portfolio, but it's important to understand that the libraries is the key mechanism to extend the language. And migration is supported through the transformation specification. Basically, it explains how to map V1 elements to V2 elements. So the key differences is that this new language is no longer based on UML, and there are several visualization options, if you will. One is graphical. Basically, you can visualize the model. So the model is still there. It's not gone. So you visualize the model either as boxes and lines or as tables, which we always had in our current portfolio, and textual. The textual is very new, but again, it's completely optional and you visualize in text. Text is not your model. And then finally, standardized APIs. I mentioned we do have those, and they are. That's a new thing, actually helping a lot the entire ecosystem. Now, for those who never seen SysMLv2, this is a short explanation about the textual syntax versus graphical syntax. So it's both are coming from our implementation, but that's how the standards define them. So the same model, again, there is a model. It can be visualized in text on the left or in graphical syntax on the right-hand side. And again, you can immediately see that probably in this case, graphical syntax is much more useful because you can clearly see what connects to what, where it's much more difficult to understand that in text, but there are scenarios where textual is more useful. And we support both, and you can use both interchangeably or one of those. I have another example showing, on the left, there is the same model represented, the same state machine model represented in text. On the right-hand side, the same model represented in graphical syntax. So this one slide describes what's included in upcoming 2026X release. So just like I mentioned, we do support textual and graphical syntaxes, and they're in sync. And I think we are the only solution on the market supporting it. the true sync of those syntaxes. Then we do support dynamic views. Specifically, you can build tables by queries, as well as you can build graphical views, basically by queries. So I never seen anyone doing it, and we do support it in 26x. Next, we'll be covering how do we support so-called model evaluation. This is a subset of simulation or execution of the model. We do support extensibility very nicely and elegantly in 26x. You can build libraries, metadata, you can define custom styles and whatnot. So I will show a brief demo a bit later. Thomas will be covering the SysMLv2 RESTful API support. You can store your models in the 3D Experience platform or Teamwork Cloud, and it's your choice which one you choose. And I often get a question, guys, are you doing anything on the web? Yes, we do. And actually in 26x, you will receive a SysMLv2 reader. I will show a demo about it a bit later. And we are working on editor on the web as well at the same time. So in here, you can see a very nice demo of the textual and graphical syntaxes and how you can use those in Cameo. So here I'm modeling a system structure, and I just modeled a port of my system on a part, and I can switch at any time from graphical into the textual syntax. So the model is still on the left. You see here, that's my model on the left, and it's visualized in text because I can switch to it. I can actually use it to continue my modeling. And here you can see very nice auto-completions supported, and I'm defining a port definition, which I will later on use to type my port. So all these nice usability features that the developers have, now we bring that to modelers. Again, this is completely optional. You may not use this syntax if you don't want to learn it or you don't like it. You just can use completely. You can stay in graphical if you want, or you can stay in textual only, or use both at the same time. So here you can see nice navigation. For example, like I want to understand where light port is defined. I can navigate to it, or I can, for example, preview the definition of that element without navigation. Again, hundreds of nice features that we support in this kind of experience. And it's, again, available in 26x. And we bring the similar experience on the web that I mentioned. This is a browser, and you can see the tree of the model rendered directly from Teamwork Cloud on the web. Right, so something that everyone likes. So we are bringing the same experience on the web. And yeah, you can open tables, for example. And I mentioned that we support tables by queries in 26x and on the web as well. We query the model and build a table. And you can define the queries yourself. This is a kind of customization we support. And then there's another completely different table that we support. Again, it's completely populated by a query. And naturally, you would expect, of course, in such a tool, web-based tool, to have textual syntax. Yeah, if you like this syntax better or more, you switch to textual editor or viewer, if you will, in this web environment. Yeah, it is fully supported. And finally, graphical views are supported. So boxes and lines, right? Yes, I can double-click on any of those. And I specifically built this example. It actually builds those diagrams by query. Again, none of these diagrams have been built by hand. So I specify a query, which in the SysMLv2 expression language, and the tool automatically builds and updates these diagrams for me. Of course, you can still do manual work, but the new thing is the dynamic diagrams. Now I mentioned the customizations and so I will just show one of the extensibility options we have in 26x. So for example, you want to create a diagram type, a new kind of diagram type for modeling requirements. So you start with empty palette here, right? And you define it in a model-based way on the right-hand side, right? And then I augment it and say that, well, I need some buttons here which create requirements, okay? So I augment my SysML model, and then my user interface refreshes. You see the buttons for creating requirements appear here. So basically, it's all model-based. All your customizations are model-based. Okay? It's very powerful. Another very powerful feature we never showed publicly is the model-based styles. So this is Toggle coming in 26x. In here, you can see a diagram, and you can see two styles. One is black-white style, and the other is color style. And you can easily switch between those two styles, and they're completely custom. For example, I am working on a paper. I can switch between two styles and embed that in my paper and go back to a color coded style. Now in here, this is a very powerful example showing again styles by queries. For example, I want to specify that if the payload of my interface is LP/LTL, it needs to be in blue. Otherwise, it needs to be in red. How would I describe it? Again, model-based way. This is complete innovation for us and something that our customers love. So in here, you just simply specify that, okay, if the payload is this, and that could be any kind of query, then we color code something using this pen color. Again, super powerful for any kind of visualizations you want. And probably one of the last things I want to show is definitely discipline integrations. We do integrate with DoorsNG, JAMA, and other Anovia and other requirements management tools in 26x. So you just connect to a requirements database on the right-hand side and drag and drop it, these requirements onto the model, and this model, and you see these requirements get imported into your systems model. So that's part of 26x. And the last thing is I want to mention is on the transition strategy from V1 to V2. So our strategy, you make that choice when you move to V2. We will never force you to do that. We will support SysML V1 and V2 in the same Cameo installation for as long as needed. So some programs will never move to SysML V1, and that's fine. Okay. And once you do that, we do support the transformation specification, so you can transform your V1 models to V2. We'll provide guidance soon how to do that. We do support APIs. We will support the most frequent use cases and the most core use cases, from V1 for simulation. And of course, we'll provide the best user experience. So I think that's pretty much it on my end. And over to you, Nerijus.
Okay, can you hear me?
Yep, loud and clear.
Okay, let me share my screen now. Can you guys see my slides full screen?
Yes.
Okay. So short introduction. I'm Nerijus Jankevičius, Senior Product Manager, working on this tool since 1997. And I was leading SysMLv2 implementation and currently focusing on analysis and simulation features. So my today's topic is SysMLv2 model execution and evaluation. And I only have 15 minutes and a lot of exciting things to show. So let's jump straight to the point. So my main focus is on SysMLv2.
Nerijus, sorry, yeah. No slides. They disappeared.
Interesting. Someone canceled my sharing.
You're back on track.
Okay, so let's jump into SysMLv2 expression language, because that's my main topic. So this is just a regular fragment of SysMLv2 model, and you see a lot of expressions in the text. So that's new exciting feature in V2 language, is the ability to easily specify any initial values and also derived values and dependencies between any parameters in your system straight in the language. And this expression language is standardized, which was not the case in SysMLv1. In V1, any expression you had in the model was not defined in the language, so nobody knew how to interpret it in a standard way. And here you see Basically, in any expression, you can reference any other part of a model downstream or upstream in your assembly, and you could even use the dot notation for the feature chaining, so you can navigate deep into the system and take that parameter into this equation. So it's very powerful, and the best part is that it's standard. So it's the tool parses that language and it just not just piece of text, but actually it parses into actual references to your model elements. This could allow us to use automation and evaluation tools to solve those equations and expressions. Another big change is that requirements are formalized. So in addition to just having a text-based requirement, you can still have that textual description, but you can also add a formal constraint, because requirements are constraints basically. So you can define your input parameters or the context or subject. In this case, you see vehicle is my subject, and you can add constraint, and constraint should evaluate to true to satisfy that requirement. And the subjects could be deeper, the parse in your structure. And so you're defining this, and then you can access it by name in a constraint. And let me go back to my slide. So in my previous example, you see my parse structure, and there are some, like you see the line satisfy requirement this and that by this. So if I put this satisfy requirement statement into my vehicle, basically I'm passing my vehicle as a subject. So I can say that this stopping distance requirement must be satisfied by this vehicle. Then I have another satisfy inside my brake. So the brake heating requirement must be satisfied by brake subsystem. Okay. So by having this, and as I said, we can parse and traverse that expression tree. We can actually solve that. So what we did, I hope you see my slides now. So you can actually click on any of those expressions or attributes in your textual view and say evaluate. So we have evaluate button in a textual editor. You click and say evaluate, or you click on any part or attribute in your model tree and evaluate. So it would evaluate that expression in the context in which you do that. So you can actually derive those values of any attribute, and also you can evaluate the requirements and see the satisfaction of requirements in this console view. But of course, it's not user-friendly. It's nice to experiment. You can actually even enter some expressions into input field here, but for the regular user, I think it's more convenient if you could play the expression and evaluation in a diagram view. So in a diagram view, we have this evaluate button here in the main toolbar, and you can evaluate all those expressions and get the values of attributes in the diagram. So we have a special annotation and different coloring. That means those values are kind of live. They are derived, and in the real model, you have an equation, and when you evaluate, you have the result of that equation. And the nice thing is that you can actually play with those values live in a diagram. You can change inputs and immediately see results. And you see, we're using different coloring. So if something fails, we have the red color icon. Okay, you cannot see the red attribute here, but basically you could see what requirement failed, and it propagates. Then you see the yellow icon, so you see that something inside failed. So you can change those values until everything is green, and if you like those parameters, you can actually save those parameters, the initial values, back to the model. So you can experiment and see, do the sizing or play with the values and save back to the model. So in addition to saving back to the model, sometimes it's nice to actually export those values and use outside in other tools or reports. So we added export to CSV feature. So you can export everything you see in that diagram in those annotations. And we even have an option to actually group those attributes, like if you have a lot of components of the same kind, like if you do rollups, like mass power rollups, you can see those attributes as columns and parts as rows, and you could see those values, including the requirement status. So it's pretty nice and can be used outside the tool. Okay, so this evaluation evaluates one particular configuration of the model or that one context. If you want to play with many configurations, there is a trait study concept built into the SysMLv2 language. It's coming from the system library. And this is just an example, one of examples how you can define your own trait study analysis. So basically you say you should list what alternative configurations or variants of a model you have. So I have 4 vehicle definitions in my model. Actually, not definitions, but like subtypes of the vehicle or individuals. And then you define what do you want to do. I want to maximize something. So my objective is to maximize the value, and the value defined here, it's a vehicle life expectancy, brake pad life expectancy. So I want to find my alternative with the best life expectancy. So this is how you define the trait study. And then you click the button, evaluate, and if you have this analysis box in the diagram, you would see a result, like in this case, it's vehicle A. Or if you have all those configurations in the diagram, you would see all those nested attribute values and see which ones do not satisfy some requirements and shown in red color. Okay. So that's built into the language, and we can calculate and run that trait study by simply evaluating that textual expression language. It's very powerful. So to make it even more interesting is to include the scripting into the language, and SysMLv2 natively allows you to extend the V2 textual language and say, no, V2 expression language is not enough. I want to use JavaScript or Groovy. So you can define your own calcs, like functions, define input parameters, and pass those parameters straight into another language. So for example, like in this example, you can define do the distributed or randomize the values, because we don't have this in the language in V2 library. Those like distributed parameters for normal uniform distribution, you can define that using other language, or you could use Groovy. Groovy allows you to call any Java API, so you could easily integrate any third-party tools and do co-simulation, co-evaluation. Or you could simply use that language to read external data, and so you could read CSV files and iterate values for the trait study. So that becomes not static anymore, but dynamic. You could do parameter sweep or Monte Carlo or so on. Even more, we could integrate other tools based on that mechanism of the language. So MATLAB could be used as a language. So you probably know in Cameo, we had a MATLAB integration in SysMLv1. So we basically ported this integration into V2. You simply say that your language is MATLAB, and you can have a native MATLAB expression here, or the script name. So in this case, it's calling the script MATLAB script, which calls Simulink. So to calculate the stopping distance, you could actually run Simulink model. I didn't click. I don't know why my slide changed. Okay. So you see a lot of powerful analysis capabilities, and it was all on the client side. So what we did from very beginning, we implemented it so it can be easily used on the server side. So we have this language evaluation component running on the server side, and it has REST API. So you can actually pass any expression as string and get the value from from the model in the repository in Teamwork Cloud. So I have a short video here. I hope it's playing. So that's REST API. So you define your expression. Okay, it's too fast. I'm defining an expression. So let's say you don't know what's in the model. So you could even use it as a query language. So show me the features in my vehicle model. You evaluate it. And in the result, you see all the attribute names. So basically, it would allow you to navigate through the model and see parameters of interest. And then if you change expression, and let's say you want to calculate that stopping distance, you just change the expression and you can get the value of the stopping distance. You know, that was the Swagger interface. It's not for everyone. It's just a REST API. It should be used in some other, it should be wrapped into programming languages or web apps. So what we did, we also shipping the Python client, which you can use in a Jupyter environment. And you simply then log into the Teamwork Cloud and evaluate any expression in Jupyter. So again, in addition to static evaluation, you could do any scripts, any iterations, data, pre-processing, post-processing, and like in this case, you see how stopping distance depends on the vehicle mass and so on. Then you can do the plotting, exports, and so on. And at the bottom, you could also see the advanced query using the same SysMLv2 standard language, which can query your model and find any subsystem of the spacecraft which margin is more than 10. So it basically does the model querying and also evaluates, so it would satisfy that condition, and it would return that only the propulsion has margin more than 10. So it's very flexible and powerful. And for everyday user, again, maybe Jupyter is not for everyone. So we also building the web interface, like a web view of this simple table view. So you could just open this view, enter any parameters of interest in a name column, and you would get the results here. Or if it's initial value, you can change that initial value here in the table. It would automatically recalculate all dependencies. And if something fails, it shows in red color. And also in a tooltip, you would see the requirement ID and name or text. And you can share this link with your colleagues. So you can do kind of analysis view of something, and you can send that URL to others to play around or just to see it as a result. And by the way, you can export it. There's an export button here. You can export into CSV. So to summarize, we have all the capabilities of SysMLv1 simulation toolkit. The only aspect is that it's all static. So we don't have behavior model execution yet. So we have full parametrics, requirement verification, rollups, trait studies, Monte Carlo parameter sweeps, scripting, MATLABs, CSV, and server-side REST API and Python client. And what's missing? So it's all available in 26, which is coming in November. And then we are working on a dynamic behavior simulation, which is coming next year in a 26 refresh versions. Okay, that's it. I hope I'm on time.
You did
Thomas?
great. Thank you, Nerijus. Let me share my screen in just a couple of seconds. So hopefully that's up in full screen.
Yes.
Alrighty, so hi everyone, my name is Thomas Uliniškis. I'm the Teamwork Cloud product manager, and we're gonna spend hopefully not more than 50 minutes talking pretty much about what we have been cooking up in SysMLv2 at the server side. So As I mentioned, I'm the Teamwork Cloud product manager. I've been with NoMagic now, Dassault, for nearly 10 years, out of which 8 I've spent at the Teamwork Cloud development team. I'm also involved in multiple OMG activities. Primarily, I'm the official 3DS representative at OMG SysMLv2 API and services, FTF, now RTF. Also, we are doing amazing work at the reusable asset specification with an OMG as well, which is called RAS 3.0. So when we started actually designing our collaborative modeling solution for SysMLv2, we were focusing around the following 5 pillars as seen on the screen. So first of all, it's scalability and performance. It's not a secret that SysMLv2 meta model is a complicated one. All of these fancy language features like formal grounding to ontological semantics, high degree of expressiveness, it actually comes with a cost that actually resides at persistency of such models. What we noticed thus far during the implementation of SysMLv2 is that the increase of model data is nearly tenfold. So if we take an equivalent SysMLv1 model, remodel in SysMLv2, expect it to be larger in size by nearly 10 times. So that's a challenge we took. That's the challenge that we enjoy tackling. And we will definitely continue doing so in further product releases past 26X. Now, to those of you aware, some of you might not be aware, we are pretty much having 3 different environments where modeling happens. It's the classical Teamwork Cloud, 3D Experience platform, the new kid on the block, which enables collaboration on EPC models as well. And last but not least, we have local model files. So we thought about, you know what, for SysMLv2, let's make it as consistent as possible. And the upcoming slides, I'll show you exactly what we did in this area. Obviously, we focused on agile collaboration. Collaboration for us comes in 2 flavors. It's the internal one and external one. Internal one, which is pretty much doesn't cross the boundaries of a single organization, single business unit. And external one is the one that does cross the boundaries between organizations, countries, and continents. So from what we learned, you need to have dedicated collaboration functionalities for both flavors of collaboration. And that's exactly the case for SysMLv2 as well. Then let's move on to software engineering. Sometimes, when designing things from scratch, it's not worth reinventing the wheel. Sometimes it's worth looking how similar problems, similar challenges have been solved in other disciplines. And when designing SysMLv2 collaborative solution, we spent a lot of time looking into software engineering. Surprisingly, or not surprisingly, they have been facing very similar challenges in there as well. Therefore, we got multiple inspirations, especially in model management area, from that discipline, which I will showcase later on. Last but not least, our server-side products have been open from day one, that they reach the market, and that promise continues with SysMLv2. We will maintain our APIs, we will introduce new APIs, and you will be free to integrate with our products. The biggest new, most likely, and maybe the most shocking one is a concept of a local model repository. So that is a game changer to how you used to work on local models before SysMLv2. So with SysMLv2, we are bringing a new notion, which is aimed at offering you a similar modeling experience to the one that you have on the server or on the Teamwork Cloud, for example, just to unify concepts a little bit, just to unify the experience that you get when switching from Teamwork Cloud, let's say, to local persistency. So from now on, you will not be working locally directly on files. You will be working on a local repository, which will have those files imported beforehand. Talking about the file formats that we will support, there's going to be a change in there. We are introducing a new file format, which is called MD as a zip. It actually highly reflects the native format that Teamwork Cloud persists data, and that is being done on purpose to ease the transition between server models and local models. Whenever you need to save off a server project to a local one to deliver to your contractor, supplier, any customer, etc., whoever has tried it, that's quite painful in non-SysMLv2 world. So we decided to address this challenge in SysMLv2 for good. Obviously, the classical MD-zip will still be in place, not in SysML, not in 26X SysMLv2, but in upcoming refreshes. The difference between MD as a zip and MD zip is that the latter is going to be more readable, more open for integrations when you need to parse it, and the main difference is it's going to be slower performance-wise compared to MDZip, which was designed with performance in mind. Obviously, the kernel standard specifically has kpar as model exchange format, so we will be supporting that as well. What comes out of this unification? So first of all, it's the unified model decomposition. To those of you previously who have worked with both server projects and local projects, you have experienced that we had approached model decomposition differently. We used to have a concept as shared packages, mounting points, indexes, etc., which do not exist in TeamWorld, right? Very confusing, especially when you switch between those two environments. Now, it doesn't matter if you're going to be working on 3D Experience platform on your MPSC model, Teamwork Cloud, or locally within local model repository, model decomposition will look nearly the same in all of these 3 different environments with a dedicated used project node in the containment tree. Let's talk about software engineering a little bit now. So what we realized is that one of the main model technical debts, one of the main reasons behind model technical debts, it's poor model dependency management techniques. Therefore, we decided to look how it's being approached in software engineering. And guess what? This has been approached in software engineering quite successfully. Therefore, for SysMLv2 model, from day one, we're bringing the following changes when it comes to model dependency management. First of all, as you already see on the screen, no more cyclic dependencies between separate SysMLv2 models. The tool will not even allow you to reach such a state that you have a cyclic dependency. This is a nightmare. Whenever you establish one, you never clean that up. With time, situation gets even worse and worse and worse. So we decided to keep it clean with SysMLv2. And then there's going to be no conflicting model versions allowed in your model, even though Teamwork Cloud already kind of prohibits doing so. But with SysMLv2, we're going to take it even more strict. Continuing on software engineering inspired solutions in our SysMLv2 collaborative environment, we are the first on the market that we are delivering a notion of model patching. So patching is a very well-known concept in software engineering, right? The use case is very simple. We have a huge code base, let's say 5 million code lines, right? And all of a sudden you need to fix a bug in there, which only concerns one single code line. Well, how do you deliver the fix? Usually you do not rebuild your entire code base, right? You only rebuild the places that have been altered by the change. Therefore, you deliver those as patches. Actually, this very well applies to MBSE. And this feature, by the way, is even available not in SysMLv2, but in SysMLv1 as well. However, we took this a bit further and we decided that, hey, model patching is a very cool feature to be used in the so-called black box, white box, OEM supplier model exchange use cases. So let's say I have a vehicle model as shown here on the screen, by the way, obviously in SysMLv2. There's one subset of that model, the engine subset, that I want to outsource from my suppliers. I don't want to work on the internal details of that. So what I do is I only define the black box level details in my model. As you can see, it only has the exposed ports pretty much, and that's it. And what I do, I simply, with the patching functionality, can extract a portion of the model, just the part-def engine with all of its contents, and serialize it into a physical patch file. What happens next, I send this subset of the model to a supplier. The supplier then works on the white box level details for the engine. It introduces new attributes, it defines the behavior aspects of the engine. Well, pretty much he delivers the entire implementation. Once he's done with white box level changes in the model, once again, he serializes only that part of the model in the patch file, which is an implementation patch file, and sends it back to OEM for integration in the final system. Obviously, with this methodology, you can involve as many suppliers out there as needed to do trade-offs whenever you receive different solutions from all of them. Now let's talk about collaboration, which does not go beyond the boundaries of one single organization. In this area, we are also seeking agility. Therefore, in SysMLv2 models, the only way to work collaboratively will be lock-free mode. What we notice actually is that in SysMLv1 world, we also have this functionality. Conflicts, they actually appear very, very rarely. Therefore, we decided not to even consider introducing locking mechanism in SysMLv2. If there are conflicts, however, we apply very straightforward conflict resolution rules. Obviously, when some more serious conflicts happen, you need to involve the end user to solve those. And in this area, we'll be working in the future to provide a dedicated GUI to solve more complicated conflicts, which cannot be addressed automatically by the tool. Last but not least, SysMLv2 is very special. It's very special because for the first time at OMG, as a specification, so to speak, MetaModel specification, is introducing another specification, which is an API. So systems modeling API and services is aimed at defining a common standard set of API endpoints for navigating and even altering SysMLv2 models. It actually comes in two pieces. It has the so-called platform-independent model level description of services, and it has two platform-specific model descriptions, which relies on two technologies. It's the RESTful HTTP and OSLC. Last but not least, also the API spec has API cookbooks, which pretty much are recipes showcasing how to use the API to achieve this or that systems engineering use case. What's our API strategy at Dassault Systems? We seek full conformance to the REST HTTP PSM API level, and actually 26X has that, as Andrews mentioned at the very beginning. But we are not stopping here. Actually, what we are working on already is we are working on custom extensions on top to enable workflows with textual representation of the model, to enable workflows, integration workflows, especially by exposing graphical aspects of the model, diagrams that is. And one of the most common questions that I'm getting asked, so does that mean that the standalone Teamwork Cloud REST API is going away? No, it's not going away. The SysMLv2 standard API is a complementary one, meaning that you can continue working with Teamwork Cloud REST API as we know it today, going forward as well. So last but not least, let's see a quick demo how SysMLv2 standard API queries work. So we have a sample model here shown in Cameo, a vehicle part definition with lots of stuff underneath it. And let's try to query for this element using the standard SysMLv2 API query mechanism. And not even that, let's try to find this part definition with all of the owned ports that it has. As you can see, it's very quick, and you get the query response in iBlock with all of the information that you had requested. So with that, I conclude, and we can open for questions. Thank you.
Right. Thanks, Thomas. And I think, yeah, I will not be sharing my screen anymore. We have a lot of questions. A number of them we answered already in the Q&A panel. Some of them I will actually still, read because they are very useful for the wide audience. So let's get started. Patty is asking, will the official Dassault made plugins work right after the transition to SysMLv2? Or is there a waiting time to transition the plugins? So the short answer is it depends. So some of these plugins, for example, the simulation toolkit for V1, it's being adapted and rewritten to support SysMLv2. So like Nedius mentioned, right? Some of these other plugins, which allow, for example, integrating to requirements management tools, I demoed also that we are working on it as well. So the short answer is not all plugins are available in 26X, but that's definitely a priority for us. All right, next question from Martin. Would you agree that the textual model representation is more appropriate for AI integrations compared to the non-graphical representation? So the short answer is yes. Again, of course, AI LLMs specifically, not general AIs, but LLMs specifically interact through text. So definitely we understand that and we'll use that as much as possible. But we have actually a pretty solid plan and roadmaps for the AI support, which not only interacts or uses textual syntax for the interaction with the model, but also other means, more direct means. Okay, another question from Alex. The syntax and operations of the expression language are hard to pull out from the kernel specification. Will you provide user-friendly documentation to help modelers learn the expression language? So yes, we are working on it. We already have recipes, and our early access program participants are finding those very useful. George is asking, why move away from UML? Well, it's something that OMG is working on. Basically, they decided to start from a clean sheet. UML was basically created for software engineers, not for systems engineers. So the idea is that we design a language from ground up for systems engineers. And that's why it was chosen to create a new meta model, kernel, and base SysMLv2 on top of it. Another question from Osama. Where are the links to early access programs? Okay, so after this session, we'll share the links so that you can read more material about it and understand more about it. Okay, then the question is, let me look at that. Okay, so another question is from Fernando. How much does the V1 OpenAPI differ from V2 OpenAPI? For example, tags helper, SEUtils, stereotypes helper. I haven't come across any V2 OpenAPI material. So there are two parts of this. One is server-side API, and the other is client-side API. So if you're looking for the server-side API, so just like Thomas mentioned, we do have SysMLv2 RESTful API available and implemented as part of 2026X release and early previews as well. And we have the Teamwork Cloud RESTful API, right, Thomas, in 2026X?
That's right.
Yeah. Now, on the client-side APIs, we had the Java APIs for V1, and we are developing the V2 Java APIs as we speak. These are not part of 2026X. And if you have specific, priorities, please let us know that would definitely help. Okay, so another question is from Alexander. Where can we find the query language that was shown in the evaluation interface and examples? It is included in some of the OMG documents or specific to the DASO implementation. Oh, that's a good question. So none of that is DASO specific. All the queries are based on the expression standard SysMLv2 expression language. And we do just support the standard. So you either read the spec or you can find some material online. You can learn this language there. And just like I mentioned, we are working on some recipes, some of the most frequent scenarios, where this language is mostly useful and to teach people. Another question is from Winton. When will OMG finalize the SysMLv2 spec? I understand that the current standard document is version 2 beta 4. So yeah, the answer is that the spec is in last finalization stages, but it is not published. So when it will be published, we cannot tell. I don't think even OMG can tell precisely, because it includes some editorial changes, and it depends on how many editorial changes there needs to be done. So it depends. But usually again, I cannot tell about SysMLv2, but usually I remember other specifications. It takes from several weeks to several months. I also seen 12 months once. So so hopefully it will not take that much time. Okay, another question is about integrations. So Torrance is asking with the connections with tools like Java. Does that mean the Syndea plugin is no longer being used? Oh, it definitely is being used. It's compliant with SysMLv1. And I know Interclax is heavily working on integrations based on SysMLv2. And they demoed during our symposium back in Nevada this year the integration of their core product with Teamwork Cloud through SysMLv2 RESTful API. Okay, so I recommend taking a look at these demos, and these demos are also available on YouTube, I think, and definitely on their website, on the partner's website. Will the recording be made available? Torrance is asking. Yes, definitely the recording will be available afterwards this session. Are these fantastic features? Synchronous textual representation, diagrams by queries, also planned for the implementation of UML. Martin, no, UML does not have textual syntax. That's the language issue, right? So no, the short answer is definitely that's only available for SysMLv2. Another question from Wilfried, connection to requirement management tools. Also to Codebeamer. So basically to Codebeamer, no, we don't have that in 2026X, but we know a lot of customers are using it and asking for this kind of integration. So hopefully it will be delivered pretty soon after 26X out, but I cannot tell exactly the date. Another great question from Michael. Does 26X support Code Collaborator? Okay, so the short answer is not in 26X, but definitely that's our priority, and we are taking another look at Collaborator. We have great ideas, but the idea is such that we want to directly render documents out of SysMLv2 models. So no need for publishing, and that's a way better approach, much more scalable, much more performant, and user-friendly, honestly. So, but we are deep in works on this. So I don't expect Collaborator to be available like right now or like in months. But if you ask about commenting capabilities, that will be pretty soon. Hopefully we'll include that as part of 2026X refresh 1. Okay, let me see if there are any new questions that popped up. Oh, another great question is on UAF version 2. So the question is whether or not UAF is available for SysMLv2. So the short answer is no. OMG is heavily working on UAF version 2 based on SysMLv2. And it's just very early stages right now. And I hope that by the end of next year, we'll have a relatively solid specification. So that's pretty much the timeline. Okay, Deepesh is asking, I wanted to ask about the model transformations, like it was mentioned in the transformation from V1 to V2 in the works, but do we also have something in the picture for V1 to V2 so that we can also provide support for companies still favoring V1? And would this be a lossless transformation? So at this point, we are focusing on V1 to V2 transformations. And yes, the short answer is that this is a lossy transformation. It has some loss because the semantics is not entirely covered by V2. It's not fully like one-to-one mapping. But the coverage is pretty good. It's pretty good, honestly. So I would say if you have ordinary models, most of the information can be transformed to V2. But SysMLv2 has things that has features of the language, which are, for example, usage-focused modeling. And if you just do the transformation one-to-one, from V2 to V2, you will not be able to exhaust V2 features. Okay, so the key thing here is the so-called post-processing. So after transformation to V2, you have to remodel some of the things you did to actually benefit from SysMLv2. So yes, the transformation is one thing, but the transition to V2 is a completely different thing. Okay, so I think we are at an hour, and we probably should conclude. I can still see a lot of questions. So, Gitana, I think you can probably take a moment and explain